Hello guys, welcome to my YouTube channel. In this video, we will talk about something called as TF-IDF, which stands for Term Frequency Inverse Document Frequency, right? So as you all seen in my previous video with respect to bag of words, it just creates a frequency table and it doesn't really give any weightage to more important words or less common words, right? So it just lists the vocabulary and creates a frequency table. So in this, no semantic meaning is preserved, no context is preserved, and all the words are given equal importance, right? The general idea is rarely occurring words should be given more importance and commonly occurring words should be given less weightage or less importance. So that will be taken care in term frequency and inverse document frequency, TF-IDF concept, okay? So let's see what each TF and IDF stands for. So TF is term frequency and it is simply defined as how many times any word occurs in a document D compared to the total number of words in that particular document, right? So here's how the mathematical formula goes. So its term frequency is equal to number of times word T occurs in document D divided by total number of words in that particular doc D, right? So this is the formula for term frequency, okay? There is more mathematical way of writing it, but let's not get confused with that, right? Now coming to document frequency. It's a general meaning, so it stands literally the document frequency, in how many documents the term T or the word T occurs. And inverse document frequency is inverse of that. Inverse of what? Inverse of out of all the documents, in how many docs does the word T occurs. So this is how we write inverse document frequency formula. IDF is equal to N. I'll tell you what N stands for. N divided by number of docs the word T appears in. Okay, in this N here is for total number of documents in our corpus, total docs in corpus. Okay, so let's say we have around 10,000 docs in our corpus for now, right? And there is a smoothing applied log 1 plus and plus 1 in denominator also. I'll tell you why we do that. And this is our formula for inverse document frequency. And in the end, we will put both together, TF and IDF together. So the end result is product of TF and IDF for each of the token or the word that we have in our documents. Okay. So now coming to why we apply this log and have 1 added to both numerator and denominator. Let's talk about that. So first, why we need log? So let's say we have assumed there are 10,000 docs in our corpus, and let's say there is a word, some word, let's say play. This occurs in only 2 docs, okay, and the denominator will be 2 because that word play occurs in only 2 documents, so the denominator will be 2. So if we divide this, we will get 5,000, right? Let's say there is another word, let's take some arbitrary word, and it occurs around 1,000 times in 1,000 docs, right? This word play occurs in only 2 docs, but there is another word which occurs in almost 1,000 documents that we have in our 10,000 docs as a corpus, right? So this will be 10. So you see the difference here. This 5,000 and 10 are way too varied, right? Way too varied. So in order to avoid these large differences, we take a logarithm scale, maybe base 2 or base 10. Okay. So natural log or base 2. We can take either of them and then apply log to that. And why we need this plus 1 here? So let's say if a word doesn't appear in any document, so this will be 0. So we end up with the problem of division by 0, right? This will give us error. So in order to avoid that, we will add +1 in the denominator. To balance that out, we will also add +1 in the numerator. So this is how IDF is calculated, right? And in the end, we will just multiply TF and IDF together to get our desired number. So what this actually does? So this actually does two things. First thing, most occurring words, right? So let me say most occurring words. Most occurring words will get less weightage rare words will be given more weightage, right? So I will show you with a practical implementation, and to do this we will use something called as TF-IDF vectorizer available in sklearn library. TF-IDF vectorizer. Okay, so now let's get started with TF-IDF vectorization. Okay, so this is the code that I had for bag of words. I'll continue with the same thing, but I'll import TF-IDF vectorizer as well. Okay, now in the same way we implemented bag of words with the help of count vectorizers, we will initiate TF-IDF vectorizer by calling that init method. Right, so this will create an object of TF-IDF vectorizer. Now, to calculate TF-IDFs for these two sentences, this is our corpus and we have two sentences in it, two docs, right? So for each word, we will calculate TF-IDF for each of the sentences, sentence 1 and sentence 2. So let's calculate that. In order to do that, we have to do TF-IDF vectorizer dot fit transform, right? And what's the parameter? It is the iterable that we have created on top. That is the list of sentences that we have. This will create TF-IDF vectors for each of the words in that sentences list, and let's save that. Okay, let me call them as TF-IDFs is equal to this, and let me convert it to NumPy array. Okay, so now if I execute it, you can see TF-IDFs. So it has created the NumPy array with calculated TF-IDF values. Okay, so in order to understand this in a better way, let me show you something. So features. So what are the features that we have that the TF-IDF actually computed? What features it has considered, right? So feature names will be TF-IDF vectorizer dot, it's the same method, get feature names, right? Okay, and if I execute it, there is some warning on deprecated, so that's okay. For now, we will concentrate on the features. So you see, these are the features. Individual words will be acting as features. Okay, so cricket, great, is, let, play, should, to, today, us, we, weather. So this is again organized alphabetically, sorted alphabetically. Okay, so now that we have these features, the words, and we have this TF-IDFs for each of those words, let's construct a data frame which will help us to read and understand for what word what's the TF-IDF value. Okay, so in order to do that, let me import pandas as PD, right? Let me construct the df pd dot data frame TF-IDFs, and the column will be features, correct? So if I execute it, I'll have a data frame created, and you can see cricket for sentence 1, it has got TF-IDF value of 0.2366, right? Similarly, you can have a look at different values for different words. Okay, so let me open it again, right? So now you see here, weather is a word which is occurring in only one document and it is occurring only once, right? Where is weather? Weather is here, right? For document 0, weather is getting 0.33262 weightage, and in document 2, that is sentence 2, it is not occurring, so it is 0. Term frequency is 0, so if we multiply anything with 0, it will be 0, right? So that will be 0. So now let's see another word, today. Today is occurring in both the sentences, or you can treat individual sentences as documents. Today is occurring in both the documents, right? So once in sentence 1, once in sentence 2. So this will be given less weightage. You can see here 0.23667 is the weightage for today in document 1, and in document 2 the weightage is 0.379303, right? Now let's see which word has got most weightage. So in document 1 or sentence 1, the most weightage is given to the word play, 0.47335, right? In document 2, the most weightage is given to let and else. Why it is given to let and else? Because let and else are appearing only in second document and only once. These two are not occurring in the first document, so those two will get more weightage, right? Coming to play, right? Play is getting TF-IDF of 0.47, but this is relatively less with respect to 0.533 because play is occurring in both the sentences or both the documents. So relatively it will have less weightage compared to the rarely occurring words which are let and us, which is occurring only once in the second document and they are not occurring in first document, right? So this is how rarely occurring words are given more importance and most frequently occurring words are given less weightage. So this is how you can get the TF-IDF vectors, and you can feed these numbers as input, these features as input to your ML and DL algorithms for your defined task and train your algorithms. Okay. So this is how we implement TF-IDF in Python using sklearn, and I hope you are clear on what TF-IDF means and how it is calculated and why we are using log and why we are using +1 on both denominator and numerator. Okay. So if you have any questions, please let me know. Reach out to me in the comment section. I'll be more than happy to explain it. So happy learning, guys. Till the next video, stay tuned. Bye bye.